when you burn everything, you believe that you have destroyed the waste. The metallurgy is really millenary because before the Egyptian, we produced copper and iron and tin and silver by metallurgy. But today, there is more negative side than positive side in the metallurgy. Unfortunately, today is not sustainable because we have high energy use, high CO2 emission, high risk of other toxic emission like chloride, sulfur, NOx, and also the efficiency is low by metallurgy because you always lose some material in the slag and some volatile material in fly ash. So the metals are divided depending on their boiling point. They go to fly ash or they go to the bottom ash. And in metallurgy we speak about slag, but it's the same. And one of the most important emissions is dioxin. Today, if you Google dioxin, you have 3 million answers. Just to tell you how it's important, this subject today. And dioxin is made when you have organic, heat, chloride or halogen, and catalyst. Because if you don't have catalyst and you burn organic and chloride, you make the very, very basic product, which is chloromethane, because the nature is lazy and they make the lower energy needed, which is methyl chloride, ethylene chloride, but never so structured molecule without catalyst. And when you have the waste, municipal waste for instance, you have the organic, from the fruit for instance, you heat, you have the chloride, and you have the metal catalyst from wires like copper or like zinc, and then you have all the ingredients to make a very good sauce of dioxin. But if metallurgy is millenary, don't believe that hydrometallurgy is very young. It's not true, because also hydrometallurgy was used before the Second Empire in Egypt. More than 6,000 years before Christ, they produced coal. The lady knows very well the coal. They produced pigment. All the pictures of the Egyptians are very well colored because they have mineral pigment. So hydrometallurgy is also millenary. And today what is very interesting is just to forget using the ore for the hydrometallurgy, and we use the urban mine. And if we use the urban mine, we don't have to change anything. The state, the man of state of art, adapt the hydrometallurgy to recover the metal, the salt, the oxide, and to convert the waste into resources. But without CO2 emission, without dioxin, and with low energy consumption. Then the sustainability is very positive. So I give you very fast a few examples are really well implemented, you know very well. You make sorting of, I have seen here several places, glass, paper, can, plastic. So today, all those products are converted in secondary raw material. So we decrease for instance, we strongly decrease the forest and the wood. Also, one big component of our society today is the car. And the car has a life also, crash or used. And then, for the cars, at the end of their life, there is a very big negative side, as before in the tires. We have pollution, visual, chemical, odor, leaching, loss of material. But there is a positive side, because very important. If you use a car as iron, thermodynamically it is already iron. You don't need to convert the iron ore into iron. You just need to smelt it, okay? Then you gain, for one car, you gain 2 tons of iron, 1 ton of carbon, 3 megajoule at 1,600, which is the production of the iron, and 800 kg of CO2 per ton. So if you use the car as raw material, you have all those benefits, and you don't import the iron from Australia or Brazil or South Africa. You just have your ore next door. And beside the iron, you recover also a lot of raw material like tires, non-ferrous, catalytic pot with palladium or platinum, batteries with 85% of lead. And this means that if you increase the recovery rate today in Europe from one normal car, like a Clio or Peugeot or the 208, 800 kg, we recover 85%. And they do the work very well, and the Commission said to automotive industry, oh, in 5 years you achieve 85. So we impose you 95. And now it's a nightmare, because the last 10% are not metals. Something very, very complicated to recycle. Because it's mixed of foam and the glass and the segment of batteries. We need to speak about batteries because without your batteries, you don't have everywhere wireless and Facebook and Google Map, etc. Then we are today the wireless civilization. So the battery are a main component of our civilization. So the growth of the battery is huge. In the 60s, we have only 2 batteries at home. Just 30 years after, we have all those products. Probably I forget. And in 2015, we have all those, and additional batteries. The last one is a postcard for birthday Hussein. Happy birthday. There is a small zinc battery inside. So the batteries are now everywhere. And due to the need between the postcard and the laptop, there is a lot of electrochemical need, a lot of power and duration and fast recharge. This means that we shift a strong evolution for 130 years between 2 or 3 metals at the beginning of the prehistory of the battery industry to 5, 6, 12, 15, and today, just in 2013, I started, we have 25 metals in the batteries. And among the 25 metals, we have 60% are lithium-based batteries. So how you can recycle batteries containing 25 metals is a real nightmare without any smart sorting and smart collection. So lead acid batteries are really very well down. I just mentioned it. It's very important to see that when you have so today, for instance, it's a reality. There is waste to resource. Europe is independent in lead. 91% of the lead comes from recycling. So there is independence, economical independence of lead industry in Europe by collection of used batteries.